Welcome to Thuma Mina Teaching. You are tuned in to Grade 9 Mathematics. Let's have a look where we are at in the curriculum. Today we will be discussing the topic similarity. So get your pen, your book and your calculator and do this with us. Now the symbol for similarity is 3 vertical stripes. And if you can remember, for congruence, it was 3 horizontal stripes. Now, when shapes are similar, we say they are the same shape, but not the same size. Therefore, if I have 2 triangles which are similar, I write it as follows. I say that triangle ABC is similar to triangle DEF. What this means is that angle A of my large triangle is the same size as angle D of my smaller triangle. This also means that angle B of my large triangle is the same size as angle E of my small triangle. And also that angle C of my large triangle is equal to angle F of my small triangle. Therefore, I can say that corresponding angles are equal. It is very important for you to remember to say the word corresponding angles, as this refers to the 2 angles in the different triangles being equal. You can also say, when the triangles are similar, that the corresponding sides are in proportion. We will get to that a bit later on. Now, when I say that triangle ABC is similar to triangle DEF, the order is extremely important. That means that angle A is the same size as angle D, since A and D are both written first. This also means that angle B is the same size as angle E, and that angle C is the same size as angle F. Therefore, A equals D, angle B is equal to angle E, and angle C is equal to angle F. This also tells me something about the proportion of the sides. Since AB is written first in the first triangle, we say that AB will be in proportion to side DE. Side BC, which is written in the middle and last, will be in the same proportion of side EF, which is also in the middle and last. Also, side AC, which is first and last, will be in proportion with side DF, which is also written first and last. Therefore, I can say AB over DE, or the other way around, AC over DF, or the other way around, BC over EF, or the other way around. Let's have a look at how to prove triangles are similar. The first proof that we will do is the proof that corresponding angles are equal. Remember that the word corresponding is extremely important. This means that angle Z is the same as its corresponding angle F. Angle X is the same as the corresponding angle D, and angle Y is the same as corresponding angle E. Therefore, I can write angle X is equal to angle D, which is given. Angle Y is equal to angle E, which is given. And angle Z is equal to angle F, which is given. Therefore, I can say that triangle XYZ is similar to triangle DEF. And I need to give a reason. Therefore, I say angle, angle, angle. Now, once again, the order in which the triangles are written is extremely important. Since X is written first, D has to be written first, since angle X and angle D are equal. Angle Y in the middle is equal to E, therefore E will also be written in the middle. And since Z is written last, F will also be written last. Now let's have a look at our first example. Prove that triangle PQR and triangle STU are similar. Now, I can clearly see that angle P is the same size as angle S. Therefore, I can write in triangle PQR and triangle STU, angle P is equal to angle S, which is equal to 60 degrees. And my reason here is given. Furthermore, I can see that angle Q is equal to angle T, which is 72 degrees. This is also given. Now, to find my third angle, which is not given, I need to apply some logic. I know that the interior angles of any triangle is equal to 180 degrees with my reason, interior angles of a triangle. Therefore, I know that this angle over here will be equal to 180 degrees minus 72 degrees minus 60 degrees. Therefore, I know that angle R will be 48 degrees. The same goes for angle U, which will also be 48 degrees since the interior angles of a triangle are equal to 180 degrees. Therefore, I can write that angle R is equal to angle U, which is 48 degrees, with my reason, interior angles of a triangle. Therefore, triangle PQR is similar to triangle STU, with my reason that I have proved 3 pairs of corresponding angles equal. Angle, angle, angle. Once again, the order is extremely important. I know angle P is equal to angle S. Since P is written first, S will be written first. Since Q is written in the middle, T will be written in the middle as they are equal to each other. And angle R is equal to angle U. Since R is written last, U will be written last. Let's have a look at another example. Prove that triangle ABE and triangle ACD are similar. But first now we have a new concept. We clearly see that angle A is in both triangles. Angle A is in the small triangle, but angle A is also in the large triangle. Since angle A is in both triangles, we call this a common angle. Therefore, I can write in triangle ABE and triangle ACD, angle A is equal to angle A with my reason common angle. Furthermore, I see that my lines are parallel. Line BE is parallel to line CD. The moment I have parallel lines, I know that I have 3 options. Either alternate angles, or corresponding angles, or co-interior angles. I clearly see an F. Therefore, I can see that angle ABE will be exactly the same size as angle ACD. So I write angle ABE is equal to angle ACD with my reason corresponding angles. Always remember to write your parallel lines with. So I write BE parallel to CD. Furthermore, I find the same reason for angle AEB and angle ADC. I see another F, which means I once again have corresponding angles. Therefore, I see that angle AEB is equal to angle ADC. So I can write angle AEB is equal to angle ADC. With the same reason corresponding angles, line BE parallel to CD. Therefore, I can write that triangle ABE is similar to triangle ACD with my reason angle, angle, angle. Once again, looking at the order, depending on which angles are equal. The second method to prove that triangles are similar is to prove that the corresponding sides are in proportion. Now, you can either put the sides of the large triangle on the sides of the small triangle, or you can put the sides of the small triangle onto the large triangle, as long as you constantly keep on doing the same. So, if for instance I look at these 2 examples, and I want to prove that these 2 triangles are similar, I'm going to say that side ED is over side XY, which is equal to 3 over 1 which is equal to 3. Furthermore, I can say that side EF is over side YZ, which means 9 over 3, which is equal to 3. Lastly, I can say that side DF over XZ is equal to 12 over 4, which is also equal to 3. Since all three of my ratios are the same, I can say that triangle XYZ is similar to triangle DEF, with my reason corresponding sides are in proportion. If one of these answers were not the same as the rest, then these two triangles would not have been similar. Therefore, I can conclude that if all three of my ratios are the same, then the two triangles are similar, with my reason corresponding sides are in proportion. Now let's look at an example. Prove that triangle ABE and triangle ACD are similar. Now, since I am supplied with all of the necessary sides, I can prove that these two triangles are similar as long as all of my ratios are the same. Therefore, I write in triangle ABE and triangle ACD. Now, I can write AC over AB. If I look at AC, I find that it will be equal to 12 plus 4. Therefore, in AC's place, I can say 12 plus 4, which is equal to 16, over AB, which is equal to 4. That gives me the final answer of 4. Furthermore, I can say that CD over BE is equal to 28 over 7, which is equal to 4. Lastly, since I see that AD is equal to 5 plus 15, I can write that AD is equal to 20 over AE, which is 5, which is also equal to 4. Now that I see all three of my ratios are equal to 4, I can say that triangle ABE is similar to triangle ACD, with my reason corresponding sides are in proportion. Now let's have a look at a question when similarity is given. This question states that we need to calculate the value of x if triangle PQR is similar to triangle STR. Therefore, we already know that the two triangles are similar. The moment they write that triangle PQR is with a symbol similar to triangle STR, then we immediately know that they are already in order as long as the symbol is in between. Therefore, I immediately know angle P is equal to angle S, angle Q is equal to angle T, and angle R is equal to angle R. Furthermore, I know that I can write all of these sides in proportion. Side ST over PQ, side TR, which is the last two, over side QR, which is the last two, or side SR, which is first and last, over side PR, which is first and last. Therefore, I can immediately write that ST over PQ will be equal to TR over QR, which will also be equal to SR over PR. Now I just need to substitute the values of the known sides. Side ST is equal to 7.5 over side PQ, which is equal to X. TR is equal to 3 over QR, which is equal to 2. Side SR is equal to 6 over PR, which is equal to 4. Now, I can either write that 7.5 over x is equal to 3 over 2 and then determine x, or I may write that 7.5 over x is equal to 6 over 4 and then determine x. I am going to choose the first option, although both options would give you the same answer for x. So I can write 7.5 over x is equal to 1.5. Therefore, 7.5 is equal to 1.5x. Therefore, x is equal to 7.5 divided by 1.5, which will give me 5. Here are 3 exercises to try by yourself. Remember, the answers will follow. See you next time when we will be discussing Pythagoras.
We hope you benefited from this video lesson. Our vision at Thuma Mina Teaching is to accelerate access to quality education. And our dream is to see learners across South Africa flourishing academically. We are a non-profit company and we are entirely dependent on public support. We produce lessons at the rate at which they are funded. As soon as a lesson is funded, it is published to the entire growing audience of Thuma Mina Teaching. Please consider taking hands with us in one of the following ways. Share our content with others that can benefit from it. A great way to support us is to find us on My School and to add us as your beneficiary. And consider donating towards a lesson or ask your company's CSI department to partner with us. We are a PBO, so your donation is tax deductible. Our contact details you'll find on our website www.tmteaching.co.za. If you want to reach out to us, please email us on admin@tmteaching.co.za.